Good morning, friends. Today we will learn about VHDL language constructs and elements. Before going to start today's lecture, we are going to revise the previous content of the previous lectures. In previous lecture, we have started with introduction to HDL, means hardware description language, introduction to very high speed integrated circuit hardware description language, means VHDL. We have seen advantages and features of VHDL language, fundamental units of VHDL language. Also, we have seen what is meant by library, how to declare the library, what is meant by entity, how to declare the entity, what is the syntax for entity. After that, we learn what is meant by architecture, what is the need of architecture, how to declare the architecture, what is the syntax of architecture. Then most important point we learn in the previous lecture is architecture modeling style. In architecture modeling style we learn behavioral architecture modeling style, data flow architecture modeling style, structural architecture modeling style, and mix means combination of any two above modeling style. In today's lecture, our aim is to learn different VHDL language construct. Now, VHDL language constructs are important elements while writing the VHDL code. They are very useful language constructs. Without them, we cannot write the VHDL code. Now, which are the VHDL language constructs? Identifiers, data objects, data types, and operator. Now let's discuss one by one. Identifiers are probably the most common operand. An identifier in VHDL is nothing but user defined name for any one like constant, variable, function, signal, entity, port, subprogram, parameter, and instances. Means it is a user defined name for any one of these. Basically, there are two types of identifier: basic identifier and extended identifier. Now, what are the examples of identifiers? Suppose you are, while writing the entity name, you will provide the entity name is, suppose you are going to write the VHDL code for AND gate, then AND1 or AND2 is nothing but your user defined name, and that is known as identifier. For architecture, you are providing the name, behavioral or data flow or anyone, that name is nothing but the identifier. Now, as identifiers are divided into the two categories, basic and extended identifier. Let's see the basic identifier. The basic identifier are used for naming all the name entities in the VHDL. They can be of any length, provided that whole identifier is written in one line of code. We cannot use reserve keyword or reserve words as a basic identifier. Means in VHDL language, the reserve keywords are like library, entity, is, architecture, of, and all the operator names. These are the reserve keyword. Hence, we cannot use the reserve keyword for the basic identifier. Underscores are the significant character in the identifier as well as basic identifier. The basic identifiers contain the underscore, but two underscores side by side are not allowed. Now, second type of the identifier is extended identifier. These are included in the VHDL language 93 in order to make the code more compatible with the tools, which makes the use of extended identifier. They are placed between the brace between the two backslash character. Means while writing the extended identifier, we have to write the name of that identifier between the two backslash character. This is about identifiers. Now, what do you mean by data? second language element or language construct is data objects. A data object holds a value or range of values of specified types. It is created by means of object declaration. In VHDL, there are four classes of data objects. Means data objects plays very important role while writing the VHDL code because it holds a value or range of value of the specific type like integer, float, you can say like array or bit type, standard logic type. Okay, these are nothing but the example of data objects. Now let's see there are which are the various four classes of data objects. First class is a signal, second variable, third constants, fourth file. Signal serves to pass the values in and out the circuit as well as in between the internal units. In other words, we can say signal represents circuit interconnects, means wire. Hence signal plays very important role to describe electronic circuit operation because it passes the value in through input port to the circuit or from output port to the circuit to the external behavior. Or we can declare the internal connections between the two different components by using the signals. Hence, it represents the circuit interconnects or wires. All the ports of the entity are signals by default. Means all ports which are declared inside the entity, they are signals. A signal is a data object which holds the list of values, and these values include current value of the signal and also the set of possible future values that are to be appear on the signals. Means whatever the value stored in the signal, they represent either current value or the possible future values. Signal represents a wire or logic in the signal in the circuit. As we are talking about the electronic circuit, a signal plays the important role of wire. In VHDL, signal can be placed in any of the following places. Means we can declare the signal inside the entity or we can declare the signal in declaration section of architecture and we can declare the section in declarative section of the package. Means entity, architecture and package consist of signals. Now, how to assign the value to that signal? Signal assignment operator is less than equal to, that is known as the assignment operator of signal. Whatever the value written on the right hand side of the signal, it is given to the left hand side. Let's see some syntax how to declare the signal. Syntax for declaring the signal is as follows. Signal, signal underscore name, colon, type underscore name. First, let's see the first example, signal x colon bit, where this signal declares the object signal object x and it is of the type bit. Initial value of the signal is 0 as bit represents only the two logical values either 0 or 1. Hence here we can declare the signal x of the bit type. Similar way, if signal having the multiple values or vector values, then we can declare in this way. In second example, signal y colon bit underscore vector 1 to 5. A bit vector, it is a type for linear array of bit objects. This is one way of defining the multiple data objects. The lowest and highest limits are given inside the bracket. If we are declaring 1 to 5, means 1 indicates the LSB and 5 indicates the MSB. Means it is a 5-bit signal. Now, second language element is a variable. A variable is also used to hold a signal value of given type. But unlike a signal, variable does not necessarily represent a wire in a circuit. The different values can be assigned to the variable at different times. And it can only be used inside a process, function and procedures. Means we can declare a variable inside process, function or procedure, that is means inside the sequential code. Now how we can assign the value to the variable? Assignment operator for a variable is colon equal to, that is the assignment operator for variable. Now, how to declare the variables? Variable, name of the variable, colon, type. Or if you have to initialize the value, then we can declare in such a way: variable underscore name, colon, type, colon equal to its initial values. Let's see some examples. Variable a comma b colon bit means here we have declared the variable a and b of the type bit. Similar way, we have declared the variable sum colon standard underscore logic underscore vector 7 down to 0. Third, language element or language construct is of the constant. A constant is an object whose value may never be changed during the simulation process. This constant contains one or more identifier. We can declare the constant inside the package, inside the entity or architecture. When constant is declared inside the package, we can say it is a truly global for the package that can be used by several entities. But when declared inside the entity, it is global to all the architecture that follows that entity. And when we declare the constant inside the architecture, it is global to the only that architecture code. Now let's see how to write a constant. Hence, let's understand the syntax of constant. Constant syntax starts with the name reserve keyword constant. Then constant underscore name, it is a name of that constant which is to be declared. Colon its type, colon equal to its values, means we can provide or initialize the value of constant. Let's see some example of constant. Constant width colon integer colon equal to 8. Here we have declared the constant width of the type integer and its initial value is 8. Then second, constant x colon standard underscore logic colon equal to 16. We have initialized the constant x of type standard logic. Constant delay colon time colon equal to 10 nanosecond. Here constant is of the delay and its type is time and initial value is 10 nanosecond. In this way we can declare the constant. Now next language element is file. Now file is very important language element. It is when file is defined as a sequence of value, and that value can be read or write to the file using read procedure and write procedure respectively. Means whatever the value are stored inside the file, we can read and write that value by using the read and write procedure. The file creates one or more file objects of the specified types. Let's see how to declare the syntax for file. File identifier colon subtype underscore indication inside the bracket file underscore open information. Means here identifier is the name of file, file is a reserved keyword, subtype indicates the type of the file, then whether what is the information to read or write the file or open the file, that information is given inside the bracket. Let's see example. First of all, we have declared the type integer file is file of integer, means we have declared the integer file which is of the type integer. Then we have declared the file f1 colon integer file. Here integer file is the type of the file f1. The basic operation that we need for reading and writing of the file are as follows. First of all, we have to declare the file type, then declaration of file, then opening and closing of file of that specified type, and then reading a file and writing a file. Means these four operations are necessary to read, write data from the file. First of all, we have to declare file type. What is the type of that file? Then we have to declare a file name along with type. Then opening and closing file of specific types, whether to open or close that file. Then read a data from file or write a data to the file. First of all, first declaration, how to declare a file type. While declaring the file, we should ensure that Host environment correctly interprets the format of data which is stored inside the file. Let's see the syntax. Type file underscore type underscore name is file of type underscore name. Here file underscore type underscore name, it is the name of that file and it is of the type underscore name. Example, type text is file of string, means text is nothing but the file which includes all the string, that is the character. Second, file declaration. After declaring the particular type of the file, we can declare the file objects. File declaration consists of declaration of objects for the file. Syntax: file underscore name colon file underscore type underscore name is string expression. Here file underscore name is a name of file and after colon what is the type of that file. Inside the bracket we have to mention what is the mode of that file, open or close, and is after that what is the type of that file is string. Okay, example, file name of the file is input file colon text open read mode is, and inside the bracket what is the string expression. Third, opening and closing of file. After declaring the file of specified types, it is necessary to open the file before using it and to close it before termination of the program. Hence, there are procedures and functions to open and close a file. Let's see the syntax of opening and closing file. Procedure file underscore open inside the bracket file f1 colon file underscore type underscore name means declare the file f1 of the type file underscore name colon in string and semicolon open kind colon in file open kind colon equal to read mode. Here read mode indicates that file is of the read mode. Reading and writing the file. We need procedure and functions to read and write the files of the declared type. Let's see the syntax. Procedure read inside the bracket file f colon file underscore type underscore name colon bracket complete semicolon value colon out type. Hence the file f of the type file underscore type underscore name, it is in the read mode. Procedure write file f colon file underscore type underscore name colon value equal to int types. Hence to whatever the value we have to write, it is mentioned in the value variable. Function end file inside the parenthesis file f colon file underscore type underscore name complete the bracket semicolon return boolean. This is about language elements which are present in the VHDL language. Now let's compare these two language elements, signal and variables. If we see the assignment operator, then signal has assignment operator less than equal to and variable has assignment operator colon equal. Second, utility. Signal represents circuit interconnects, means wire inside the circuit, while variable stores the local information. Signal, it can be global and variable, it can be local because it is placed inside the process, function or procedure. Behavior. Signal, it update signal value is not updated immediately in the sequential code. New value generally only available at the conclusion of process, function or procedures. While variable values are updated immediately. New value can be used in the next line of code. And uses. Signal it can be used inside the package, entity, architecture. In entity, all the ports are signals by default. Variables, they are only in the sequential code, means we can use inside the process, function or procedures. This is about our language elements. Now next language elements are data types. A set of values and set of operations is called data types. as data types are very important. What type of objects you are going to declare, what type of data you are going to declare, these are mentioned by using the data types. Hence, there are 9 classes of types in the VSTL. Scalar type, composite type, access type, array type, record type, predefined VSDL data type, unsupported data types, subtype, and physical type. Where scalar type are the values having the no elements. Values of this scalar type, values of this type have no element. In composite, values of this type consist of element values. Access type provide the access of objects of the given types. Now let's see how to declare this data type. To declare the data type, starting with the reserved keyword type, type underscore name. Type underscore name is the data type, is type underscore definitions. And after that, we have to declare the objects type underscore name. Let's see first data type scalar. Values of this data type have no elements. The scalar type values cannot contain any composite elements. Now, which are these data types? All the numerical types, that is integer, floating point, physical values. This can be specified with a range that contain the set of possible values. Then means all the numerical types, integer, float, physical, these are nothing but the scalar types. Second type is the composite type. An object of composite type is a collection of other objects called the elements. The element can be of any scalar, composite, or access type. It is not allowed to use file types as elements of the composite. Means the object of composite type, it is a collection of other objects, and these objects are known as the elements. And that elements can be of any type. They may be either scalar, composite, or access. Hence, but it is not allowed to use the file type as a file type as an element of composite. Means we cannot use the file as a composite element. Third data type is the access type. Access type, it allows to manipulate the data which are created dynamically during the time simulation. Means while simulating the VHDL code, whatever the data generated, that can be manipulated, and it allows by access data type. And its exact size is not known in advance. Hence, it can be scalar, composite, or other access type. File type is not allowed here. Again, this is the limitation. We cannot include file type in the access. Only objects allowed to be the access of the type variable. Next most important data type is array. Array, it is a composite objects and its elements are of the same subtype. Each of the elements is indexed by one or more indices belonging to the specified discrete type. Here, index range determines how many elements are present in the array and their ordering. And index can be of integer type. I think all of you familiar with the array. Array is a collection of data. It has index, and index range determines how many elements, and index can be of integer types. Next most important data type is the physical. Physical type allows while defining the measurements unit for some physical quantity like length, time, pressure, and capacity. These are the physical types. Means these physical types allows the measurement units for physical quantity. Means to measure a length, to measure a time, to measure a pressure and capacity. The range is specified at the beginning of physical type. The range specified at the beginning of physical type. It defines a minimum and maximum value of a given quantity which is expressed in the base unit. Now, next most important data types are subtypes. These subtypes declarations are used to define the subset of type. Using this subtype is a powerful way to use the VHDL type checking to ensure valid assignments and meaningful data handling. Most probably, these subtypes are used in every program. Let's see data type, value, and example. Bit data type have value 1 and 0. Its example, let's see P is assigned 1. Bit underscore vector, it has value array of the bits, means more than one bit. Let's see example. Data out is assigned 110001. Then boolean is again another data subtype which has value either true or false, and we can assign p is assigned true. Integer, all the integer values are included here from, you can say, negative and positive values. Example, C is assigned C plus 2. Real values, all the real values we can declare or use for the VHDL program. P is equal to V into R. Physical values, all the physical measurements like time, pressure, length. P is assigned 1 after 6 nanoseconds. Character indicates all the characters which are written in the single apostrophe A, B, and character data is assigned X. String, it is array of character. As we can, let's see the example. Message is equal to message plus make plus 1. Now this is about the subtype, but in VHDL there is another most important facility or feature to define the own data types, and it is known as the predefined and user defined data types. Let's see some predefined VHDL data types. IEEE VHDL some predefined VHDL data types are present inside the package. Hence, the inside the packages and libraries. The library IEEE includes the predefined data types. Hence, IEEE VHDL describes two site-specific packages. Each contains a standard set of values and operations. The standard package and the text IO package, these are the important where this describes the data types. The standard package of data is included in all VHDL source file by an implicit use clause, and text IO package defines the types and operation for communication with the standard programming environment. Let's discuss some predefined VHDL data types. Bit is the most important data types. The bit type is predefined in the standard package as an enumerated data type with only two allowable values 0 and 1. Example, signal, bit signal 1, comma, bit signal 2, colon bit. Bit signal is assigned 1. Bit signal 2 is assigned not of B signal. Here, these both signals are of the data type bit, means we can assign the values either 0 or 1. Second data type is bit vector. The bit vector type, it is a predefined in the standard package as a standard one-dimensional array type with each element being of the bit type. The size of a particular vector is specified during the declaration. Third means in bit vector we can assign more than one bit value. Hence, that size of that vector is specified while declaring the value. Let's see the example. Signal yes colon standard logic vector. Inside the bracket we can write 3 down to 0. Here 3 down to 0 is the size of that vector yes, and 3 indicates the MSB and 0 is the MSB. It's total 4-bit vector we have declared. And more last important data type, predefined data type, is a Boolean. Boolean type, it is a predefined in the standard package as an enumerated data type with two possible values. Boolean have two possible values of true and false. This is about data types, and data types plays important role while writing the VHDL code for any electronic circuit. Without data types, we cannot declare the signals, variables, and different data types. Now, next most important language construct or element is operators. Let's see. Operators are useful to perform the operation between the two signals. Now, what type of operation we can perform on the signals or data objects? We can perform the Boolean operation, we can perform the comparison operation, we can perform the shifting operations, we can perform the arithmetic operations, and we can perform the concatenation operations. Let's see one by one. To perform the Boolean operations, we are using the Boolean operators. And all these Boolean operators are nothing but to perform the NOT operation, we can use the Boolean operator not. To perform the AND operation, we can use the operator AND. To perform the NAND operation, we can use the operator NAND. Similar way, we can use the operator OR, NOR, XOR or XNOR. They all are of the type either bit or bit array type, or you can say standard logic or standard logic vector types. Means we can perform the single bit or vector bit operations. Second type of operation we can perform on the data objects are nothing but the comparison. Comparison means to compare the two values, whether they are equal, whether they are less than, whether they are greater than values. Hence, these all operators are equal, not equal, greater than equal to, greater than, less than equal to, less than. Most of the types, most of the data types for comparison operators are non-numeric. But most of the data types are for comparison operators are numeric, but they are not expected behavior for non-numeric types. The next most important operators are shifting, to shift the data to the left side or right side. Along with sometimes we have to perform the arithmetic shift operations. SLL and SRL are these are the shift left logical, means logic to perform the logical shift we can use the shift left operator. To perform the logical shift to the left side SLL, to perform the logical shift to right hand side SRL. Similar way we can perform the arithmetic shift SLA for the left shift, SRA for the right shift. Then rotate left, rotate right. For this to perform operation on the data objects we can use ROL and ROR. All the bit array types are useful all bit array types are applicable for the shift operations. The next operators are arithmetic operations. Arithmetic operation plays important role to perform the arithmetic operation on the given data types or signals. Addition, subtraction, multiplication, modulus value, remainder, absolute value, then power. These are the nothing but the arithmetic operators. And the given data types for the arithmetic operators are numeric type. And if we have to concat two values or two words, we can use the concatenation operator ampersand. And for data types for this concatenation is array types. This is all about operators. Hence, in this lecture, we learn about different VHDL language constructs like identifier, data objects, data types, and operators. These language constructs plays very important role while writing the VHDL code for describing any electronic circuit operation. Thank you.